we have question 5 here. The question says h of x equal to 2x minus 3 for -2 less than or equal to x and less than or equal to 4. The x-intercept of h is q. Now, in the previous videos, we did question 5.1 through question 5.4. Now we're going to do question 5.5. The question says P is the point on the graph of H that is closest to the origin. Calculate the distance of OP. All right, it is important to note that the shortest distance OP, okay, the shortest distance to the point P must be, excuse me, the distance that will be perpendicular, okay, to h of x. That's the shortest distance. I'll give you an example here. Let me just take a rough example. Assuming that the lines were parallel over here, and then if the point is here, and okay, let's say the original point was there, another point over here. Let's say, okay, I want to put the points, placing the point. The original point is over here, and then we have another point over here, and then there, and then there. So now the closest point, the closest distance will be the one that makes that is perpendicular to the other line, okay? Because these ones will be longer than this other line, the vertical line here, okay? Because this line is perpendicular to this distance is perpendicular to the other line. I hope this makes sense. But now let's see in calculations. I'm gonna move my board over here. We have question 5.5. We're looking for the distance OP. All right, excuse me. The distance is given by, the distance formula is given by, of 2 points, is given by square root of x2 minus x1 squared plus y2 minus y1 remove minus y1 squared. Okay. Now, or the same distance can be written like this. The distance AB will be the distance squared. Okay. If you don't want the root, you can write it like that: x2 minus x1 to the power of 2 plus y2 minus y1 to the power of 2. So let's first draw the same graph here so we can visualize the problem better. Graph over here. Okay, so we have it there. So we want the distance OP, okay, the shortest distance. Okay, wait. Now let's do. If we know that at O here, O being the origin, its coordinates must be 0, 0, and then P, the coordinates is given to be x, y. Now, if you need to find the distance, we're going to substitute. Okay, P being a point on the line H. Okay, it means y has the value of because it's like y equal to 2x minus 3. So we can substitute the value of y by 2x minus 3. Okay, so the distance will be then the distance OP. So the distance squared OP will be, or maybe I can just write like this. I can write OP squared. Okay. So OP squared will be equal to x2. So it's x minus x1, which is 0 to the power of 2, plus y2 is 2x minus 3, 2x minus 3 minus 0 to the power of 2. And then that makes OP squared will be equal to x squared plus 2x minus 3 to the power of 2, because 2x minus 3 minus 0 will be just 2x minus 3. And then we can expand this. This is like x squared plus 2x minus 3 times 2x minus 3. And then this will be x squared plus 4x squared minus 6x minus 6x plus 9. And that makes x squared plus 4x squared minus 12x plus 9. And then we can combine like terms. Here we have like, excuse me, we have like 5x squared plus 4x squared makes 5x squared. Makes 5x squared. And then minus 12x plus 9. Now, if I need to find, this is the distance, OP. So if I need to find now its numerical value, how can I do? Even before finding a numerical value, how can I say, how can I find the minimum distance here? Okay, we can find the minimum distance by using the differentiation. Okay, the derivative of this function will be, I say, because the derivative of the function, if it is set equal to 0, it will determine the minimum or the maximum. Okay, so in this case, we want the minimum. I want to set, I want to write this f prime of x equal to 0 determines the min or the max. Okay, in this case, we will have the minimum. So I'm going to say the derivative of the function makes 10x minus 12, okay, equal to 0. So x will be equal to, 10x will equal to 12. That means x is equal to 12 over 10, which means x is equal to 6 over 5. Okay, we can do this because the derivative of the function determines the minimum or the maximum. In this case, it will show it will determine the minimum because there is a minimum here. There is no maximum because it's a straight line. It is stretched endlessly. Now, another way of solving the same problem, if someone may not be comfortable of using the derivative, we can also find the minimum by using the quadratic formula. Okay, let me split the board like this, and I'll move it over here. We can also do that by using the quadratic formula that is x is equal to minus b over 2a. Okay, this also determines the minimum. So we can find x by saying, okay, the x value will be minus b is negative 12, so negative 12 all over 2a, 2 times 5. So here x will be equal to 12 over 10. That means x is equal to 6 over 5. So we have the x coordinate. To find the y coordinate, then we can substitute, okay, in the formula. We can sub it over here, okay. Therefore, because this is OP squared, therefore, OP squared will be equal to 5 times 6 over 5 of, okay, 5x squared minus 12x plus 9. We sub in then the value of x, which is 6 over 5, and then 6 over 5 over there. Again, we can use the calculator to find OP squared. So we can say 5, open bracket, 6 over 5, close bracket to the power of 2, okay, minus 12, open bracket, 6 over 5, okay, close bracket, and then plus 9, and this is equal to 9 over 5. So dp squared is equal to 9 over 5. But we don't, OP squared. OP squared is equal to 9 over 5. But we don't want OP squared, we want OP. OP will be the square root of 9 over 5 here. And then OP will be equal to 3 over root 5. But we can rationalize this. We can write 3 root 5 over 5. That the distance, or if we want to find its numerical value, okay, I can just take the answer to the power of a half, which means dividing by square roots 2. Okay, it's the same thing. Okay, you see, This is if I press SD, okay, this is the same value as 1 point. This is equal to 1.34. So therefore OP equal to 1.34 units because the distance. Okay, there are different ways of solving the same problem. So okay, maybe I can look at we can also do the other ways. Maybe like when we use the gradient formula, because we know two lines of paper. We said these two. Where is it? We said that to be the shorter distance is when we're going to when these two lines are perpendicular. Okay, so now we can use also the gradient formula to show that the two lines are perpendicular, and then substitute again in the distance formula to find, and it's also another way of solving this. Okay, thank you.